Hello, everyone. Welcome. Thank you for joining us today. I'm assuming this is your first reInvent session for 2025. Woo! All right. Thanks for giving us that privilege. So today, we are going to talk about bringing or bridging structured and unstructured data using AI agents. Let me begin by asking you a question. How many of you here are building AI agents, or maybe they're running AI agents in production, or you're experimenting with it? How many of you? Wow, quite a few of them. Like, anybody want to tell me what kind of data you're using for these AI agents? Is it going against unstructured data, like files in S3? Okay, all right. Is there any data that is in relational data sources like structured data? Okay, yeah, a few of you, yeah. So usually in enterprises, a lot of knowledge that we have of all these enterprise systems from last 15, 20 years is the data is logged in relational databases, right? So that's the predominant data storage mechanism in enterprises, large enterprises. And we also have a lot of unstructured data over the past 10, 15 years because we have so much of data that's being generated in all forms and shapes. So this talk is about how do you use AI agents to bridge that data that is in different silos. In structured data and unstructured data, you use AI agents to bridge all of that together and have an intelligent system that can go across these data silos. This is a code talk. So we will be demonstrating building an application, AI application. You don't need laptops. If you try to follow along when we are doing, it's probably not, not enough time for us to type all the code. So we'll be using some, snippets, VS Code snippets to bring in blocks of code. But you'll generally get the idea how to build this type of application. My name is Anil Murari. I'm a senior solutions architect with AWS. I work with our nonprofit financial industry customers. I've been with AWS for 5 years. I'm joined today by my amazing colleague, Rafia.
Thank you, Anil. Hello, everyone. My name is Rafia Tapia, and I'm a senior solutions architect, also working with nonprofit customers. I've been with AWS for a little more than 6 years now, and really excited to share some of the code we've created for this code talk. So we can start.
All right. Yeah.
All right. So the first thing we'll do is we'll kind of briefly talk about the architecture of the application, the code which we will be building today. On the far, let's see, your left-hand side, you'll see there's a UI application, right? We've written that in Streamlit, nothing complicated, but that UI will be able to take a user question and then be able to answer that user question via two types of data. One is the unstructured data, which we have shown on the top yellow pane on the architecture diagram. In the unstructured data would be coming from Bedrock knowledge bases. We have one slide where I will be talking a little bit more about Bedrock knowledge bases. And then the structured data, which will be coming from Aurora database. Now, if anyone who don't know what Aurora is our managed relational database service. We support MySQL, PostgreSQL, and some other databases. But for this demo, we will be targeting PostgreSQL for all the structured data. Let's move on to the next one. So before we go in, I just want to kind of make sure everyone knows what are the SDKs and the agent tools we will be using. So we will be building our agent using Strand SDK. Is there anyone who has already done some work with Strand in this room? Oh, nice.
Yeah, we have a couple of hands.
Nice, very nice. All right. So Strand allow you to build a single agent as well as multi-agent where the agents can talk with each other. Strand, supports MCP as well as A2A protocol. Here, we are showing you a simple agent where a prompt is sent to the agent has certain tools built into it, and based on the tool, it will be able to provide the service which this prompt is asking for, right? So that is the model, a simple agent, single agent, which we will be creating in today's code talk. The next is about how do we access unstructured data. Now, how many of you have written RAG applications? Okay, I see quite a few hands, right?
Quite a few of them.
Yeah. So you guys know, right? The way when you write a RAG application, we take our data, most likely unstructured data, maybe in a PDF format or Word format or plain log files, and then we convert that into vectors, because that's what our LLM understands, and then be able to use that the knowledge which is stored in those unstructured documents, and be able to provide AI solutions on top of it. Now, Bedrock knowledge base allow us to build all that RAG infrastructure very effectively and easily. And this is what we will be showing you today, that we will be taking some of the files which has some content in, let's say, Word document, and then we will be putting it into a Bedrock knowledge base and be able to query that via our agent. Now, because of time constraint, we have already created a knowledge base for our code talk, but if any of you are interested in knowing how to build a knowledge base from scratch, please come and talk to us after the session, and we'll be more than happy to point you to some resources.
Okay. All right. So this is the application that we're going to build today. So let me play this. Let's see. All right, so no surprise here. We both are from the nonprofit group, so we picked a charity use case. So we're building a charity chat assistant, a chatbot, that will go against structured and unstructured data. We have all the campaign information, donation information in a relational database in Aurora, and we have some unstructured campaign-related data in a S3 bucket, which is we are accessing through our Bedrock knowledge base. So as you can see, if you ask some questions that needs it to go against the relational data source, the AI application that we are building, the agentic application that we are building, will figure out what is the right data source to go to and get that data automatically from that corresponding data source. So we're going to see all of this and how we're going to build this. All right, let me switch to my IDE mode.
All right. And for most part, we will, some of the UI aspect, we'll try to, take it out very fast, because there's really nothing, which is extraordinary or something that you guys might be interested in learning today. But so the reason why we have this UI, so we can show you a complete agent, right? But as Anil is bringing the code, you'll see that we'll start with a very basic structure of the UI, and then. We'll start with showing you a very basic UI skeleton. How.
Yeah. So apologies for that. So as you can see, I'm using my favorite IDE, Kiro, here. So if you're not familiar with Kiro, it is a an IDE that Amazon supports and released recently. It's a IDE where you can do vibe coding and also spec-driven development. We're not going to do any of that today. We're just going to demonstrate building this application. But you can use any IDE for that matter. So I'm going to start with an empty folder here. already have some files here. Let me quickly go through what those files are doing. I created a Python virtual environment of 3.12, and I have a requirements file that with all the libraries that we're going to use today. Rafia talked about strands agent and agent tool. Yeah, go ahead.
So if you are working with Strand, there are two packages. And by the way, right now, Strand only is supporting Python. So there are these two packages which you need to make sure you bring it in your environment to be able to use some of the APIs and tools we will be showing you. One is Strand Agent and the other is Strand Agent Tools.
Yeah, and another file I have is run.sh. So we're going to build a Streamlit app for a UI app. So this run.sh, it just sets up my environment. If there's no virtual environment, it creates one and it starts my Streamlit app at the end. So that's all it's doing. So just by, to save some time, we have these two files already here. So let me start by creating a new file. I'm going to call that app.py, and we're going to start putting some code into it. Right.
So this app.py will have most of our UI code in it.
Yeah, so as you can imagine, you don't want me to be typing in front of you all this code and probably, going through that pain of looking at me typing. So what we did is we are using VS Code snippets, so to help us just bring in code that we want. So we're going to first just build that shell of the UI that we showed earlier. So nothing fancy here. We're just going to bring in some snippets. This first one is doing imports and then setting up some constants. Like for those of you who probably noticed, on the left-hand side, we have some sample questions and things like that. So this is just bringing all those things. Again, this file is not the most exciting part. Other files are. So I'm going to just quickly go over this. This is going to set up my theme for the app, which is like a dark theme. And then I'm going to just bring in the snippet for the chat interface. So again, like I said, there's nothing much here. We just brought in a shell of a application, Streamlit app. There's one thing that I do want you to note, though. I commented out this piece of code, which we will uncomment later, which will add in the capabilities of the agent. For now, it's just doing nothing. So let's try to run this and see what happens.
So you'll see that right now the UI is really nothing intelligent, right? Even if you ask a question, it might not be able to answer it correctly. So Anil, why don't we ask a question?
Yeah. So this is the empty application. So let's see if we can ask a question. I'm expecting an error to come because we don't have any agentic capabilities yet. As expected, there is an error here. So let's move on to a little bit more exciting part of the session today. Right. If I can kill this one. All right. So I'm going to add another file. I'm going to call that agent.py.
Yeah, and this file will have our core logic of the Strand agent, which you'll see we'll be building it later on.
Yeah. So I'm start with just getting some import statements.
Right.
And yeah, go ahead.
So as we are building this agent, we'll walk you through line by line, right? The first thing, of course, we need to import some packages. Particularly, we need to import the Strand packages, and we have some other packages like Boto3 because we will be going against Aurora database and Bedrock KB and so forth. The next thing you'll see that because we are going to be going against LLM model, here we are using a model ID, which is Claude model. So our agent will be using Claude to, when a user gives a question, it will take that question, it will feed that question into the agent. The agent, of course, has to use a LLM to be able to answer that question. And the model it will use is going to be Claude. Now, Strand SDK do allow you to talk to any LLM, even those LLM outside of Bedrock. We've chosen it to be Bedrock, a supported LLM, but if you are doing it, you're free to use any other LLM. And then the next thing we are doing is declaring some inference parameter like maximum token allowed and temperature and so forth. So now the first thing, the code Anil has put in is that the code from line 18 to 22 is the base model we are creating, right? We are using a model ID, which is a Claude model ID. We've given certain parameters. Then the code of line, which Anil just put from line 28 to 29, or actually to 32, is using the strand agent to just create a base agent. Now this agent has no intelligence into it. We just wanted to show you 2 lines of code how an agent is created. So you'll see it's as easy as instantiating an agent object, right? That agent object takes 2 things. It takes a model ID, which we've already built in from line 18 to line 22. It takes a model object, and then the second thing it takes is a system prompt. Now, at this point, the agent is really just a blank canvas. No intelligence has been built in.
Yeah, notice in the prompt we said, don't make up answers. Just if you don't know, say don't know, yeah. Right? So let's run this application again and see.
But Anil, before you run this, I think you have to uncomment the...
Yeah, very good point.
So Anil remember he showed you in the app.py, he had commented some code, because that code was what was calling the agent. So let's uncomment and go through that again, right?
Yeah, thank you.
Let me just explain that code, Anil.
Yeah.
What's your uncommented?
Let me first uncomment this and
yep.
go over that.
So the code which Anil uncommented, right? That code, what it does, it first makes sure that the agent object is not in the state of the Streamlit. So Streamlit maintains there's a state management aspect, right? So first it's going to check if there is already the session state has an agent object. If it does not, then it will create that agent. The same agent which Anil just created in the agent.py file. So that's what this code is doing, and we've just uncommitted. But keep in mind, at this point, all it's doing, the Streamlit is going to be calling our agent. Our agent has no logic, so you would not expect much functionality. But when he run this code, you might not see some intelligent answer, but at least you won't see the error which you saw earlier.
Yeah. So let's ask the application the same question we asked. How many members do we have? And let's see what it says. So it says, I don't have access to your organization's current membership data. So it's basically telling us that it doesn't know the answer.
So at this point, we've completed the entire structure of our code, right? We've built the UI, we've built an agent which does not have much intelligence, but at least is functional. And then as we move forward, we will start building more intelligence into it.
Yeah, so let's begin by adding code to retrieve data from the knowledge base.
Yeah. So strand, remember the architect diagram which I showed, and the slide after that, we showed that an agent can have tools in it, right? Strand allow you to create your own custom tool, and it also come up with lot of ready to use tools. Today you'll see that we will be using one custom tool and one which is already available to us from the Strand SDK.
All right, so I added the retrieve tool here. For this retrieve tool to work, we also need to set some environment variables.
So let me, as Anil is typing this in, let me explain what retrieve tool is. Retrieve is a out-of-the-box Strand SDK tool which allow you to query Bedrock knowledge base. You don't have to write any custom code, okay, to access knowledge base. It does it everything. The only thing you would need, you need to create a Bedrock knowledge base, which, as I mentioned earlier, we had already created. And the code which Anil just put in on line 26, you'll see that the knowledge base, when you create a Bedrock knowledge base, the knowledge base gives you a unique ID. And this is the unique ID which we have kind of hard-coded here to let retrieve tool know which knowledge base it has to go through. I'm going to stop here in case if anyone have any question on the knowledge base.
So one quick one, like as I'm kind of following, listening, writing, would you mind if time permits, just give it one more rundown after all these wrapped up?
Sure.
Yeah, absolutely, yeah.
Sure. But just to recap, okay, when you are creating knowledge base, you identify your data source where your unstructured data is coming from. Most likely it will be Word document, PDF documents, whatever. And then the knowledge base, you also, when creating the knowledge base, you also say where is what is that vector database where you will be storing that. All you have to identify is the data source, the vector store, and then the knowledge base does all the heavy lifting for you. Okay, once you go through that, it will give you a knowledge base ID, which we have put it in here, so we can let our Strand agent know, oh, this is the knowledge base you have to use.
Yeah, I have to put in a disclaimer here. I know we hard coding these IDs all over the code. This is probably not how you would do it if you want to take this to production. You want to store this in some parameter store or some other external configuration store. But this is just easy for us to demonstrate this way.
Yeah, and as part of the retrieve Strand agent, it has to have, again, the knowledge base ID as well as the region. Now, there are two ways you can do it, right? You can actually give that in two pieces of information to retrieve tool via environmental variable, which we are doing it here. So if you look at the code on line 29 and 30, this is where we establish an environmental variable where the knowledge base ID and the region where that knowledge base is created is injected, right, into the environment. So the retrieve tool will be able to pick it from the environmental variable and will know where to go. Okay.
So
all right.
we are assuming the knowledge base in the vector database is ready to be used.
Exactly. Because we had a time constraint, we did not go through that exercise of creating the knowledge base.
Any standard patterns for embedding or to create those vectors that you want us to?
So, go ahead.
With Bedrock knowledge bases, it's a few clicks, right? So you just we can stay after the session and.
For the specific format of the data, for example, if I have the data in a Word document, right? Any best practices you want to suggest that if you have a Word document or the JSON format, right? What embedding models we can use? What the size? How we can get it?
So Bedrock supports So Bedrock supports two embedding model, Titan and a Cohere model. The chunking strategy, it's a topic which is definitely a very important topic, but I think if you want, we can definitely talk later on. It would be way out of scope for us to focus on chunking, but it's an important thing. Let's talk after the session.
That is not right. The answer would
Absolutely, yeah.
All right, so let's.
I'm sorry, Anil, there's a question.
Yeah.
Is out of the box.
Yes, it is.
Can it be attached with any other vector store like OpenSearch, or it has to be Bedrock knowledge base?
Retrieve is for Bedrock knowledge base. Okay, but there are, and by the way, the Strand tools, it's a community development tool. So tools are coming up every day. You might be able to find tools, which can go to other data.
All right, so I ran this application again. Now let's go back and ask the same question we have been asking. How many members do we have? And let's see what it does. It's doing something now because it's not saying I don't know. All right, so it it looked in the knowledge base and came back with some answers. And it clearly states here, like, based on the information I found in the knowledge base, this is some like number of donors we had, but it's clearly not coming from the structured relational data, which may be more accurate. So our next step is to extend this to go to that.
Yeah. So now, because what we had some documents which were related to our campaign, and it had some data in it, but the answer was not 100% accurate. The 100% accurate answer is sitting in our databases, right? Our database is where most of our enterprise data is, or especially when you are already going against your enterprise application data, right? So now what we will be doing, we'll be creating a custom tool. That custom tool, what it will do, it will take a prompt from the user, try to answer if this prompt can be answered through our relational database data. If it can be, it's going to convert that into appropriate query language and be able to retrieve that data. So for that, the first thing we will do is create a
yeah, I'm adding that custom tool.
Yep.
That.
So all Anil did was in the agent definition, we already had put in a retrieve tool. Now he also created a query SQL DB tool, right? We have not created this tool yet, but that's the purpose of the tool. So now we'll create the tool. The entire logic of that custom tool will be in a separate file, and that's what Anil is doing. Let's call that file query underscore SQL underscore db.py. And this is where we will build our custom tool. So of course, the first thing we need to do is import all the appropriate packages, which we'll do first thing. Again, strength, agent and tool is one of the fundamental packages you need to bring in, and that's what we have. We also have Boto3. Boto3 is, again, anybody who have used AWS SDK, that's a Python SDK to access most of our AWS services.
Custom tool you will build using strands, or you will be consuming using strands?
We will build the logic and then we will feed it into strand.
Yeah, so this custom tool is just a Python script. So strands will use this.
Yeah. But there are some hooks of strand, right, which we need to put into this code so that we can feed it into strand. And you'll see that the next step, that's what we will be doing, right? So the first thing Anil is doing right now is actually writing that code, and you'll see on line 6 to 9, right? How do you take any code, any custom code you've written, and make sure that that code can be converted into a tool for strand? Okay? So all you have to do to take that code and convert it as a tool for strand is annotate that, create a function, put whatever your logic you need, in that function, and then make that function annotated by this tool annotation. So, all you need is the tool annotation. Once you have that, and once you feed that into the strand understand that whenever it needs to answer a user using the tool, it will run this function. Whatever is written in the function, it's going to run it. Okay? So I'm going to just make sure everyone is clear about how the strand plumbing is happening. Right? It's very simple as just one annotation. Okay. Now, what we have done, because we don't want to put all the logic into this one function, right? We're going to be creating a supporting class where most of our logic is going to be. And in this particular tool function, all we will be doing is calling the different methods of that supporting class. Okay. So, so let's first no.
Yeah, I brought in some constants and then.
Okay, fine. So let's go back to the tool line, right? So.
Tool, yeah. Sorry. Go ahead.
Okay. So again, the first thing you probably need to do is create the.
Yeah. So
class,
I
right?
added an empty convenience class here, so I'm going to initialize that.
So this is the DB structure data agent class. Okay, it's nothing but a supporting class which will have most of our data, most of our logic. Now the constructor of this class takes 4 pieces of argument. The first is the ARN of where our Aurora database is. For those folks who might not have worked with Aurora, when you create a database in Aurora, it gives you a unique ARN through which you can identify the database. So that's all we are doing. And you know, as Anil has already mentioned, this is not a true production ready code, so we are kind of hard coding things here. But what Anil did, Anil, can you scroll up? He defined few constants, and you'll see that, you know, in this 4 constants, we've defined where our database is coming from. So we've defined the ARN of Aurora. Line 8 is an ARN for the secrets manager. So as a best practice, right, whenever you are accessing a database, of course, you need the credentials for that database. As a best practice, you should never hard code those credentials in the code or even in config files, especially if you are publishing that code into some sort of a repository, right? So Secrets Manager is one of the AWS services which makes the storage of credentials very easy and convenient. And that's what we've done. We've stored our database credentials in Secret Manager, but here we are just bringing the ARN of that Secrets Manager. Then the other constants which Anil declared was the name of our database, which is called NPO_membership. Here you'll notice that we also have identified a LLM, which is not a Claude model which we had used earlier, but we are using a different NOVA model. Now, first of all, why we are doing this, I want to take a minute to explain that, okay? Our agent itself, so agent is communicating with LLM, and the tool within the agent is also communicating with LLM. For the agent communication, we are using Claude. For the tool which will be part of the agent, we are using NOVA. The reason we did that is because we wanted to make sure you guys understand that you can use multiple models for different things, right? The model evaluation is a big component when you are creating AI applications. So just so that we can give that demo, we purposely are using a different model here.
By the way, is this legible to everybody, like in the back, or do you want me to increase the font? Yes, thank you. I should have done that.
Thank you. You know, I could also not.
But is the tool not just being used for RAG? Because you already have that Claude agent. This tool is just reaching out from Aurora and feeding back to that agent, Claude agent, right?
So an agent has a RAG component and another component which is going against structured data. RAG is going against unstructured data.
The previous tool.
Yeah. The retrieve tool was going against unstructured data. This custom, so now you have 2 branches of data.
And you'll see why we need another model, or we could have used the same model, but why we need an LLM model at all for this tool, you'll see, you know, yeah.
Right.
You will keep both, or you will just switch one to other?
No. So we will make sure the LLM is smart enough to decide, should I be going against the RAG tool or should I be going against the structured database tool? That would be the Claude model. Okay? So now everyone is clear, right? So far what we've done. Yeah, please.
Model that we are using, which is basically to figure out what your structured data is and create a query on it.
Absolutely. Exactly. You nailed it, okay? There are 2 things, right? One is we need to make sure that LLM understand our database. We want to make sure that if it's going to answer any question, then, you know, and you'll see as we move forward, right? But everyone is so far clear on the way we've defined the plumbing for strand tool and the creation of the helper class, right? Now, we will start building function in this helper class to do different things. The first function we will build, okay, it is so that our LLM can understand the database schema. without understanding the database schema, it cannot answer, right? So the first, Anil, what are we calling this function?
I think I pulled the wrong function. Sorry, yeah, go ahead.
Okay.
Generate schema.
Okay, yep. So now, every relational database, okay, has a capability via some system tables or, that you can actually use that capability to query how your database looks like. What are the tables? What are the columns of those tables? What are the data types of the columns and so forth, right? So the first function which we are showing, it's called get table schema, and you'll see that this is nothing complicated, okay? All it is going to be doing, Anil, can you show that query, please? Go.
Yeah, so I need to pull in the query too.
Yeah, so this is a query, and again, we are defining it as a variable here. In order for us to go to PostgreSQL and be able to pull what's in the PostgreSQL, this is a query. Okay, if you are using, let's say, Oracle, or if you're using Microsoft SQL Server, every database has a mechanism, and that you probably just have to change this query syntax for whatever database you would be using, but the rest would be same, right? So the first function Anil put together was get table schema. Anil, did we already add that in the tool?
No, let me add that.
Okay.
So I'm going to add that thing.
Yeah. So we created our helper class. Then the second thing we will do, we will actually query the SQL, query our database. In our case, is Aurora PostgreSQL. We are querying it and saying, give me the entire schema in a JSON format, and that is now being stored in the db_schema variable, which is on line 82. I'm going to pause here, make sure everyone is clear on it. All right, no question? Oh, you have a question?
So is the schema alone is enough, or some sample data also?
So right now you'll see schema is enough. But yeah, sample data might, I don't know, depending on what you're trying to do, you might think that, maybe providing a sample data in a prompt might make it more effective.
Yeah, you'll see how we wrote the prompt so that without the sample, it will still get it.
Okay, so once we know the database schema, I'm sorry, I have a question.
One question. Let's say you import the schema with this, but you want to add some more information to schema because the column name is probably not very intuitive for PL.
Yeah.
Is that something that you can?
Yeah, so very good question, right? Maybe you can then inject some sort of a transformation logic before you send that schema to LLM, right? That's one way of doing it. Another way of doing it might be that transformation logic you can embed in the system prompt which you will be sending to the LLM. Whenever you send anything to LLM, you do provide some context, some prompt, right? Yeah.
Just adding to that question, if, for example, my schema has foreign keys and stuff, and sometimes the LLM needs to do like 2 or 3 queries to help it. There you have only the table schema with the columns.
Yeah.
Is it possible to put in the schema the relationship as well?
Absolutely. So right now we chose our schema, which is very simple, okay? But if there was relationship which we need to make sure, because let's say right now when the queries which will be answered from will be most likely from one table. If that is the case, then we will make sure that the prompt which we are providing has that relationship. So the SQL generation has the joins in it.
Yeah, got it.
Right? At the end of the day, when you are querying a database, you are only going against, sending a SQL statement. Your SQL statement has to have that relationship built into it, right? All right. So now once the second thing we will show you is that system prompt generation, right? See, remember, that system prompt gives that intelligence, okay? In your case, you could have added like the system prompt that, hey, this transformation should happen. You could have added that relationship information. Let's see what we are producing in the system prompt.
Yeah. So
So I'll go a little bit line by line. Can you move up a little bit? All right. So this is the system prompt we are creating. We are saying, the first thing we are saying, you are an AI assistant that create system prompt for database query. Okay. At this point, we are asking LLM to create a prompt which itself has the database schema embedded into it. So we're going to take that prompt, we're going to embed with the user question and send the whole thing together. I'm going to make sure everyone got it, right? Sure. Let's say you have a user question, right? User question now needs to be sent to Claude model to answer. In order for us to send that user question to the Claude, we need to build a context which we will be building through the prompt. Everyone clear so far, right? That context which we will be building needs to have that database information into it, right? So instead of us hard coding that context, what we are telling Nova model, use the schema which you got, give me a prompt which then I'm going to subsequently send to Claude model so that it can tie the database schema with the user question. Okay. Yeah,
yeah, we'll be here after, so if you want to just go over the code again, you know.
But this, so here we are saying in the prompt, hey, look, your job is to create a smart prompt with the database knowledge embedded in it. We are giving it the schema underscore JSON on line 96, which holds our schema information in a variable, and we've built this whole thing, and now we're going to be sending it to the LLM. And at this point, all the LLM did was gave us a smart prompt, which we will then be able to send it to Claude model.
And where the user prompt is coming into this.
Yes,
yeah.
We'll see that.
We will see that. Okay. So now we got our, the first line was our getting our schema. The second line was creation of that system prompt. And in this system prompt, we provided the db underscore schema to this function. So at this point, the line 137, now we have a prompt which has our SQL our schema embedded into it, right? Yeah.
Any specific reason why we are passing this information to other agent? Like this agent should be intelligent enough to answer and build a query, right? It has the context of the question and as well as the schema.
So yeah. So we are building just a tool for the agent, right? What the agent will do, the agent takes the user input, sends it to this tool. Now this tool, along with the schema it has, is going to come up with a SQL query if it can be answered, right? Yeah. All right. So the third is, now we got our database schema, we got a prompt. Now the thing is, we need to tie these two things together. We have to now ask a LLM to generate a SQL query if that SQL query can be, if the user question can be answered through a SQL query. So let me rephrase this, right? Let's say my prompt was, and by the way, our database is related to a membership model, right? It has a table like membership, events, campaigns, donors, those kind of things, right? But what if I ask a question, what is the capital of France? Now, that question cannot be answered from a SQL query from my database. So, when I send my schema and my user, the LLM will say, well, these two things don't match. So it cannot come up with a valid SQL query. So the third function is, it actually is now taking the user input, knowing the database schema, is going to go to the Nova model and say, can you provide a valid SQL statement which can answer this particular user question?
In your previous statement, you said that you go back to the cloud model and then it comes back again. Now, what I understand that once you have see the system prompt, there's no need to go back to the cloud model. You can directly go back to the Nova. You can then SQL to execute.
But the cloud model is
That's the first step, right?
yeah.
Yeah, right.
The cloud model will go not only with the database, it will also could go against the RAG.
After the schema generation, there's no need to go back to the cloud model.
Right. Yeah, the Nova model is doing that.
Exactly. Yeah.
You marry the schema with the context, go to the cloud. No, you go to the Nova, get the SQL, execute it.
Yeah. So the cloud model will only be utilized to say if I need to go to the database.
But once it gets the context of the schema,
Yeah.
then
Yeah.
to the second ball,
Yeah.
that might be fit for
Yeah, because here you'll see if I can generate a valid SQL for the user prompt, it's going to not only give me a SQL, it's going to actually give me the data of that
Yeah, simplest way to think of it is this tool could have been static, right? Like you just, if this is the query, this is the SQL query. If this is the user query, this is the SQL query. We are putting intelligence into this tool that we are building using the LLM model to generate that query dynamically for us. Quick time check, we have 14 minutes, so we'll move a little bit faster.
Okay, so now we got our system prompt. The third thing what Anil is typing in is actually getting those two plumbing things together, right? The database schema and the user prompt. So the third thing we will have is a helper function called generate SQL. Let's type this in and let's go to the definition of generate SQL, please.
Yeah.
So again, in our supporting class, we have a generate SQL. Let's go a little bit and make sure we understand this, right?
Oh, where did I put it?
Where is it?
All right. Yeah. Right.
Okay. So if you look at this, generate SQL. Okay, what it did was it took the user prompt, which is in the question variable, and at this point it has a system prompt which has the database schema into it. It defines the model, which is our Nova model, and then it builds, it asks LLM, hey, look, LLM, this is my schema, this is my user. If you think a valid SQL can be generated out of it, give me that SQL. So once this function is executed, you will have the valid SQL. But now what we are also doing we want to make sure the valid SQL is in some sort of a delimiters so we can extract them very conveniently, right? So Anil, you need to
add the delimiters. Yeah.
Okay, so in our going to Nova models, right? When we are saying, can you create a valid SQL? We are also going to say, if you can create a valid SQL, make sure the valid SQL is in this SQL start delimiter and SQL end delimiter. Okay, once our valid SQL is in there, so when the next function which is going to pull that SQL out knows exactly from the output which I got from the model where I have to pull the SQL out from. Oh, everybody okay for this? Okay. All right. So, the line 226, right, is where by this time, if everything is working fine, I would have a valid SQL. Then line 227 is another function which is extracting that SQL. All it's going to do is going to take the output from LLM, make sure between those two start and end delimiters, I can pull the valid SQL out. Okay, nothing complicated here. Yes, please. I'm sorry, can you... Yeah, so it's a very good question, and I'll give you, maybe we can run an example of that. our model in our database, a table is called campaign, all right? What we will do, instead of using the word campaign, we will use the word event, for instance, in a prompt, okay? And that's the beauty of some of this, doing it through LLM. The LLM is smart enough to understand that there's a semantic meaning between event and campaign. So even though the database itself has the word campaign in the table, it associated with the word event and be able to get the SQL correctly. That's a no, but that's a NOAA, but that could be part of any LLMs, right?
Okay, so this question is completely different. For example, I give you a schema that has column name as column 1, column 2, column 3.
Yeah.
Right? And so by seeing this column 1, column 2, column 3, nobody knows what it is.
Exactly.
There is also information about this column.
Yeah.
So if I pass the information schema, column 1, column 2, column 3 is Chinese.
Yeah.
But
You can understand.
yeah, so if the column names are so cryptic like that, exactly, you can pass the data dictionary also into your prompt, and then it will know like how to do it.
Not another tool. You don't want to have so many tools. You might want to make this tool smart enough that along with maybe along with your database information where you are pulling the SQL, you can have it. Oh, by the way, we did not talk about memory.
Yeah, so in reality, if you're doing this in production, for example, you don't want to keep going to the database and generating this system prompt over and over again because the schema is fixed, right? Maybe it changes once a month or only when you want to do that update when the schema changes. So you can use memory tools like, for example, if you're deploying this using Amazon Agent Core where you run your AI agents, there is a feature functionality that comes with Agent Core that's called memory. So it can keep track of this kind of caching that you want to do with the
See, and your data dictionaries could also be part of that memory, Exactly. You don't keep on changing, you don't change your schemas in your data dictionary so often, right? So make it, again, for this particular, we've already said it's not 100% production ready because we wanted to make it so that it's easy for everyone to understand what's happening.
All right, so I added also a function to execute that same SQL that we just got, and I'm going to run this again.
Yeah, so after we extracted our SQL, we wrote another function called execute SQL. Again, no brainer there, right? It's just going to take our SQL, it knows how to query a Postgres SQL, it's going to feed that SQL into Postgres SQL. If you were going against any other database, Oracle or any other, you probably will use whatever mechanism of querying that database you're using, okay? As long as you have a valid SQL, that's all you need to talk to a relational database.
Right. So I'm asking the same question. Theoretically now, it should be going to the database to get the exact number of members that we have. Let's see if we can do that, or if I missed some step somewhere, it happens. Well, looks like.
Right. So you see now the 5,000 member is not coming from RAG, okay? Anil, maybe we should tell them where it's coming from.
Yeah, so this is coming from the database. I mean, you see there's a toggle here that will actually show you how the query is going.
Yeah, so if once, maybe let's run it to show the audience, because you'll be able to see whether it send it to the SQL tool or the RAG tool. So when the question was asked,
I asked another question: what membership levels exist? So again, this is in the database. We have 3 membership levels. So you can see that when you expand this tool usage, it will show you what it does. It went to the database. It got these results. But if I'm asking a question like, did we run an event to support elderly? This probably will go against the knowledge base instead of going against the database.
Because this information, it's not in a database. So
This decision
Claude is making, exactly. Once Claude make the decision which tool it's going to use, if it database needs to be used for the answer, then Nova will come into picture.
One thing I do want to highlight is in our app.py, our system prompt is, in our agent.py, our system prompt is still basic. But our application is simple enough that the LLM is able to figure out that it needs to go to the database or structured data. But it's always a best practice to give good system prompt to make sure your LLM behaves in more or less the way that you want to behave rather than just leaving it up to it. So, we could have replaced this system prompt with something more robust like
Yeah. So right now you'll see when Anil is going to put a very smart system prompt. Because our code example was so simple that Claude was able to find this out. But imagine if you had multiple knowledge bases, multiple databases, you were even doing transformation, you were defining data dictionary. When you are making that complicated type of agent where it's accessing multiple structured and non-structured data sources, your system prompt becomes very, very important, right? The more information you provide in that system prompt, the more intelligent Claude would be to decide which tool it's going to use.
Yeah, you're kind of defining your agent's personality with this system prompt. So it is very important to have that good system prompt. All right. So I want to wrap this up. We have only 2 minutes. As you can see, we just built a demo application. It's not production ready, but if you have built this application, if you want to deploy this in AWS, you have multiple choices. You have choices like you can run this in AWS Lambda, container services like ECS or EKS, or use our latest and greatest runtime for running these agentic applications, agent code. It's because it's just Python, right? So you can run it in any compute. We are not deploying this into anywhere. We're just running it off of an EC2 machine that's sitting in AWS, but theoretically you can pick any of these choices to go there. And finally, if you want to learn more about agentic AI, there are some resources here. And please don't forget to submit survey for.
And we will be here after the session, so please feel free to stay. I don't know if you can stay in this room, but we can definitely go outside, and then we'll be happy to answer any question. I know, sir, you wanted to give us like a one more rundown.
I even have a smaller question.
Okay.
Okay.
Yeah. So we'll stay here. We can chat. Here. Yeah, absolutely.
And we can also, talk about. I'm sorry. We can talk about your question. Okay.
All right. So yeah. Sorry.
Yeah. I'm sorry. I didn't get. Yeah. So you want to know how to create a knowledge base? Of course. Yeah. We can share.
Yeah. We can do that too. Yeah. Share the code. All right, we will get it up on GitHub and maybe share it. If you can connect with one of us on LinkedIn, we'll make that.
Yeah, well, actually, we were going to share the code even
before
the session, but it didn't go through our review yet.
If you go to the app, you pick the session and you submit the.
So thank you all for coming and.
Yeah, thank you very much.
We will be.